Okay, so with this one, we've got the log, so we've got the things. So we've got to remember our log rules. So who can tell me what happens when we add logs of the same base? So we're adding here. Oops, sorry. We're adding here. What can we do? What's the rule? Do you remember? When we add, we multiply. But what I might do first is actually change this log one. I'm going to change that where I'm going to move the 2. So what I mean by that is, so I'm going to leave this bit here at the moment. And I'm going to change this one to, so remember when there's a 2, when it's timesing, we could also write it as that, couldn't we? We can move that 2 back up there to the power. So that was one of your log rules. So then I can do that. Now, when you add logs, you multiply them together. So we can also we can know that 3 squared is 9. So I'll just write that in there so you don't get lost of what I've done. So I might just put that, because I know 3 squared is 9. Okay, so I'm putting that in there as well. Now I know when the rule is when we add logs, we multiply the numbers. So it's going to be log 10, and because we're adding, it'll be x times 9 there. And I'm still leaving that other one over there. Okay, so then I'm left with log, Okay, so then I'm left with log 10 9x equals log 10 12. All right, so if I bring this whole thing over an equal sign, it's like it's adding over that side, so it would be subtracting on this side. So now I've got log 10, but because I moved that over, I'm left with nothing on that side. All right, so now when the rule is when you are minusing, that you divide these numbers here. So you write the log out. So the rule is log 10 9x divided by 12 equals 0. Yeah. And then we could keep going, and I can say, I'm going to do that turn the power trick round. So I'm going to say 10 to the power of 0 equals 9x over 12. Okay, and then I've got, what's 10 to the power of 0 is 1. So 1 equals 9x over 12. So then you can rearrange this, and I'll bring the 12 over and then divide. So 12 over 9 equals x. So what would that equal? That'll be 4 over 3. I'm just simplifying that fraction there. All right. So there's that way. So that's that one. Anyone got any questions on that bit? No? Just going to move this up so I can do this next one.
Yeah, miss.
Yeah?
Where you went 10 to the power of 0, I just got confused.
Okay, so that bit here, yeah, so where I've converted that to that, is actually a rule. So we, you would have written in your notes, or you would have seen early on, where we said a to the power of x equals b can also be written as log a b equals x. Okay, so it's just a rule you have to know that you can change it around. Okay, so see here, so what I've got that rule, it says a to the power of what it equals. So I've done 10 to the power of what it equals and got that bit, yeah?
Yeah.
And then equals the b. So here is like the b part. Okay? Yep. So you definitely, guys, need to know that. And you know what? Sometimes it is, you know it in your mind is a little bit hard. So what I suggest is you learn, like, just writing that down off by heart and write it on the top of your page. you know, when you're in the test, so that you can just swap it around and you can follow the pattern. All right, that's what I would suggest to do. Okay, because it's a little bit mind tricking maybe to do it in your head, especially when you haven't done a lot. Of course, we've done a lot more, so we're used to flicking it around. Okay, all right, so this next one, so here I'm going to do exactly that pattern that I just showed you again. So I'm going to say the 2 to the power of b is the same as this. Yeah? So, sorry, this question said just to work out what x is, so we're solving for x. So really all I can do is go 2b, I'll bring the a over, minus a equals x. And it doesn't matter that we've got letters, that's all you have to do. You're showing what x equals in terms of, you know, whatever's there. All right, so sorry, I cut this. I was taking this out of a question thing, and it did say solve for x. All right, so let's have a look at this one. So this one, again, we can change. So I'm using the log rule where I know that this 2 can be moved to the power there. So I'll do that. So I can say log 2x squared. So I'm just changing that back to that. And then what I'm going to do is, I know when you add logs, you multiply those numbers. So it'll be log 2x squared times a, if you like, equals 0. So I can tidy that up and just write ax squared equals 0. And then again I'm using that rule where I said it can be written, we're using that rule. Okay, so I'm going to do that again. I'm going to say 2 to the power of 0 equals ax squared. So I'm trying to find out what x is. I'm just solving for x. So anything to the power of 0 is 1. So I've got 1 equals ax squared. I'm just trying to get x by itself. So I'll move the a over. So 1 over a equals x squared. And then the opposite operation to squaring is the square root. But we're going to remember to write plus or minus. Square root a equals x. Now, sometimes you can get multi-choice where this could be in a multiple, like written in a few different ways. So I'm just going to show you those few different ways. So first we could have it like this, what we found. Next I could say it could be, it's like saying the square root of 1 over the square root of a equals x, and this is plus or minus, and this is also plus or minus. So because we can do the square root of 1, which is 1, so my answers could end up being 1 over the square root of a, and we could have plus or minus, either option of those there. Okay, so or that could equal x, or they might decide that they might put a to the power of a half, because that's the same, so it could be plus or minus. So you just got to know that the answers can be written in different ways. It depends on what they have, and your answer, if it was a short answer, we're going to accept all of this. Yeah, we'd accept, all that you do. We can see that, we read it, that's fine. In a multi-choice, probably only one answer is going to be correct, so you need to be able to adjust it. And they'll do it on purpose. They'll probably won't put what the calculator shows you. They'll have something else put there. All right. Okay, so if log 3 plus log 2 of 4 of x equals log 2 of y, find y in terms of x. So what we might want to do here is I want to get the logs like near each other. So I'm going to move this guy over the equal sign. So what I'll have is, so I'm sort of moving that whole term over, and it'll become minus. Okay, and I do that now, and I can see, because I've got a log rule for if you minus, remember we divide these numbers. So I haven't touched the 3, I've left that there, but I'm going to have log 2y divided by 4x. Alright, so it could be written like that, or I could put, I'm just going to write the log part first and say it equals 3. I'm just showing you. So really, it doesn't matter what side you have it, but I'm going to move it to that side because of what we said about our rule. So remember I said a to the power of x equals b can be written as log a to b equals x. Yeah, so I'm going to use this again, that rule again. Okay, so if you learn this bit and you can write that little statement off by heart, it'll help you, because you're going to go, all right, I'm going to say 2 to the power of 3. So 2 to the power of 3 equals y over 4x. All right, now 2 to the power of 3 we can do, can't we? That's 8. Yeah, so we're going to pretend we wouldn't have our calculator for this. So I've done 8, and we want to get y by itself, so I'll just move the 4x over, so it's dividing on that side, it'll multiply on the other, and then 8 times 4 is 32x. And so there you go, we've found it. We've found y in terms of x. All right, so we can see, I would say this thing is probably going to be the most important thing that you're going to have to learn for your test, because it's sort of coming into everything and how to solve it. So we're going to look at a few of these. So sketch the graph, just to go over sketching. And it says show all intercepts and asymptotes. So I just drew, we've got to remember our basic exponential graph. So just remember, so it asymptotes on this y equals 0. And then remember your basic log graph where it asymptotes on x equals 0. All right, and then we will see certain moving. So if I did this A1, so when you're going to sketch it, just make sure you rule these little lines. You've got y and you've got x. Now it's just moving. So an exponential graph is asymptoting on the x-axis. Yeah, so it'll asymptote on here. This guy moves it down 1, so we're going to see it. We're going to pop in here that y equals -1. There I've drawn my asymptote. Okay, and then you might just want to think about, say, the y-intercept is when x equals 0. So you'd have y equals 2 to the power of 0 minus 1. So that's 1 minus 1. That equals 0. So you just, oh gosh, sorry, I'm a bit wobbly on the iPad. But there we go, and it goes through 0 there. And you should probably, it says showing intercepts and asymptotes, so I'm probably set there. As long as my shape is pretty good, that's okay. Okay? Alright, so that would be that one. I'm probably missing just labeling that x. Just label your axes. Sorry, that equals -y. Alright, so that would be that one. If we'll just do, might just do this one. I'll just do C with you guys. So with the log, just remember with this one, okay, so that we can see what type of transformations are happening, remember that this probably, you should probably have it with just sort of x by itself. So what I mean by, I don't want the 2 there in front of the x, because I want to see how it moved around from our basic one. So what I'll do is I take -2 out, okay, and that means I'd have to divide everything in there by 2. And that would leave me with -3 on 2, and it'd be plus x. So the reason I'm doing that is so that you can technically see. So if I just wrote that a bit different, you can see it's x minus 3 on 2. So what has happened, is you've actually moved the graph to the right, because remember that means right when it's negative in there, means you've moved it to the right 3 on 2. So it's gone right 3 on 2. So this basic log graph here is moving to the right. All right, so if we just did that step, yeah?
I'm confused with the -2 at the front.
Because I want to get, see here, this x is negative, yeah? And I just want it positive. So what I did is I'm taking -2 out. So see, if I multiplied this out, you'll end up back with this. You will. Yeah. So if you take it out like that, then you can easily see the moving, because this -2 is just a dilation, yeah? So it's sort of hard to see that in your sketching, so you don't worry, but you need to see the moving, because if you look at it, so we know that this graph asymptoted on -3 on 2, right? So on the right. So see, up here is our normal log graph, so we've moved over 3 on 2. So if you think about your asymptote, it will be x equals 3 on 2, roughly 1.5, yeah? So our graph, so that's what's done there. But now we have to really think about this negative in here, because the x is negative, that negative reflects in what? Who remembers? When your x is negative, it reflects in the, does anyone remember? It's actually the y-axis. Yeah? Is that what you're going to say?
Yeah.
So really, if it wasn't negative, we would look like this, the log like that. But now it's, because it's negative, we're going to reflect that line in the y-axis or in the asymptote. So it looks like that. Okay? So this is the final answer, is the red line. Okay, so we've got like that. And we're going to say that we've got our asymptote there, that's still fine. So you might rub the green line out, because the answer is actually. So let's go get our intercepts for that. I'll keep writing in red so we know that's our final answer. So the y-intercept is when x equals 0. So if I go into that log 10, 3 minus 2 times 0. So you end up with log 10, 3 minus 0, which is 3. Okay, so that's the y-intercept. So up here, when x is, so you can just put that in there, so that you can just write 0 log 10, 3. That's fine to do that. Yeah, if we didn't have our calculator, just leave it as log 10, 3. That's fine. And we need the x-intercept would be when y equals 0, like that. Sorry, I'm gonna move this all up. Hopefully it works. Yep. So yeah, when we've got that one, so I'm gonna use that the trick again, where I'm gonna say where I'm gonna say 10 to the power of 0. So 10 to the power of 0 equals 3 minus 2x. So 10 to the power of 0 is 1. 3 minus 2x. So bring the 3 over. That'll be 1 minus 3 equals negative 2x. So I get, sorry, running out of room, negative 2 equals negative 2x. So negative 2 divided by negative 2 equals x. So 1 equals x. So it broke through here. The x-axis intercept is 1, which, so I just write 1, 0. Okay? All right, so that would be me. The only things that I'm missing on that graph is actually drawing with a bit of steady hand, which I definitely can't do. on this and just put your little labels on there. All right, it's a bit mess, but just to go over that. Okay, this next one, the function has a range of, so they just want the ranges, probably in a multi-choice question. So just, even if it's on your paper, don't worry, just sketch what you know. So this is a normal exponential, but this, which would normally look like that, an asymptote on this line here, but that moves it down to y equals -1. So it actually looks like that. So think about the range. What values is the y taking on? What's the smallest value the y can be? It never quite touches -1. And then how high can it go? What would I put? To infinity?
Infinity.
Yeah. Okay. So there's that one. So I would, when I'm doing these, you probably want a little, just sketch it quickly so that you're not making a mistake there. All right. Let's go the inverse function of this one. So you'll see they write all this where x can take on any number, making y any number, whatever. That's what that means. All right. So we've got the function, find the inverse. So we know that f of x is like writing y, and then when we find the inverse, we swap it around. And then I'm going to use that thing that I've been talking about. So I'm going to say 2 to the power of x equals this bit. Okay, and because I'm going to try to get y by itself, I'll bring the 5 over. So there we go. So you might write the inverse equals, now you can write it like this if you want, 1/5 to the power of x, same thing, yeah, whichever way you like. And you've done that one.